Alrighty, so today we're talking about section 7.1, which is where we start talking about something called the sampling distribution. Right, and so the idea here is that we're looking at a probability distribution, right, but whose values are obtained from, that was a horrible handwriting, from a particular sample statistic for all samples of size n. Right, so the first one we're going to talk about in next section is the sampling distribution of the mean. We're actually going to talk about it in this section. Sorry, I got them mixed up. They're very closely related. I'll be honest, if I was going to write a book, I might have combined these next two sections. But if we're talking about, say, if our particular sample statistic is x bar, right, so let me do it in words, is the mean, right, so if you remember when we're talking about the mean from a sample standpoint, that's x bar, then what it means is that we have a population, and we're going to take every sample of size n, right? So you would get these values. You never actually do this by taking every sample of size n and finding its mean. Right, so that would be what you would do if for some reason you needed to find every value of the sampling distribution of the mean. But we don't want to do that, right? The whole point of what we're going to be doing when we get down to analyzing is that we don't want to ask everybody in the population, right? So luckily for us, we have some nice knowledge about this. It turns out that if x bar is your sampling distribution of the mean, right, then the mean of that sampling distribution is the mean of the population, right, and the standard deviation of that distribution is the standard deviation of the population, right? So the subscripts are there generally in all these types of problems to distinguish what we're taking the average of, right? Because now that we're in this situation of sampling distributions, there's a lot of things to take the average of. There's the population, which is what we get here. There's the new sampling distribution itself, right? X bar, right? This guy here is the mean of a single sample. So when we're talking about sampling distributions, it does not suffice to say the mean or the standard deviation, right? You need to know what you're meaning the mean of. What do you mean the standard deviation of? So what this is saying is that, I forgot, I got sidetracked by what I was saying. There we go. That finishes out the formula. So this is saying that if we know the average of the population, then we know the average of this sampling distribution, right? And if we know the standard deviation of the population, then we can find the standard deviation of the sampling distribution. And another nice thing is that if the population is normal, right, and we mean normal like we've been talking about for the last chapter, not any other stupid definition of normal, or if n is bigger than or equal to 30, x bar is basically normal. Right, well, I think we get into a little bit more there later. Maybe not. This might be kind of as close as we get to it. But it turns out that one of the things about the normal distribution, maybe one of the reasons why it's called the normal distribution, is that a lot of things wind up looking like it when they have some nice properties, right? And for our purposes, we're going to say that if the population started out being normal, or if our sample size is at least 30, then we're going to go ahead and treat x bar like it's normal, which is handy because we have all these tables to figure out probabilities there. Right, so let's see. Let's do something of a problem. There's not a whole lot we can do with this, but we can kind of work it out. So a particular study says that children begin reading at an age of 5.7 on average, with a standard deviation of 1.1. What is our sampling distribution of the mean if we consider samples of size 50, right? So what this is asking is what sort of distribution x bar is, right? And so the first thing to notice is that while there's nothing said about the population, we do know that the size is 50, right? So maybe I should have written down the first thing we might notice is that n is equal to 50. That's a good thing to look for first, because we need to know whether or not we're normal, right? And if we're not normal, then we're a little bit stuck, right? But here we notice that n is equal to 50, so we know that x bar is normal, right? Now we need to figure out if the problem has told us what mu for the population is and what sigma for the population is, right? And that is exactly here and here, right? So it tells us that the age is 5.7 on average, right? So that's another word for the mean. And it flat out says standard deviation is 1.1. Right, so this means that mu of x bar is going to be 5.7 as well, because that just copies over. Sigma is a little bit different, right? We have to take the sigma from the population and divide it by the square root of n. right? So this 50 is where that 50 comes from. So when I plug that into my calculator, I get 0.155. So that's going to be our sample distribution for this problem. Right? So that's really all we can do after this section. All of the fun stuff to work on this and actually get some data out of it comes in next section. So we're going to leave off here and hop back on this sort of thing next time.